Preventive Medicine, presented by the Harvard Medical School and the Lowell Institute, with Dr. David D. Rutstein, Professor of Preventive Medicine, Harvard University, and Mr. Parker Wheatley, General Manager of WGBH TV. The Facts of Medicine is made possible by a grant in aid from the John Hancock Mutual Life Insurance Company and produced in the studios of WGBH TV, Boston.
Dr. Rutstein, why all the controversy about fluoridation?
Mr. Wheatley, I wish I knew. This is really a very serious question because there are strong feelings about this whole question on both sides, really. And perhaps you might ask the question of me at the end of the program after we present the facts. And we'll give you tonight just exactly what we think is available in the medical literature on what happens when you put fluoride into water in terms of possible harm, in terms of the benefits, and in terms of how it should be done if it is desirable to do it. Now, Mr. Wheatley, fluoride is a powder. I have some of it right over here, a little bottle. You see, it's a white powder. It comes out of rocks. And this white powder it is extracted from rock, or the fluoride is gotten out and a special salt is made so it can be placed in a water supply. This particular material is just all over.
All over?
It's everywhere. It's in our soil, it's in our rocks, and we almost can't avoid it. As a matter of fact, if we were to say we would eat no fluoride, we'd keep fluoride out of our mouths completely, we would have to stop eating completely. Because it is in practically all the food that we eat in small amounts.
Small amounts? In
small amounts. And we'll talk about the exact amounts. Now, the amount of fluoride that's recommended to be placed in a water supply is 1 part in 1 million. And let me show you here. In other words, if you took this medicine dropper and we wanted to put into 1 million drops of water, which would be the amount in a third of a bathtub, let's say.
A big bathtub?
In a big, well, average-size home bathtub. This is how much fluoride we'd put in, if we can see this drop. Just that much. And no more. That's 1 part per million. And perhaps we should put this on the board so we can use this as a reference point throughout the rest of the program, so we can discuss how much this is. Let's put down 1 ppm. 1 part per million. This is the recommended concentration in order to prevent tooth decay. Now, but before we get too far into this, let's make one other point about the distribution of fluoride around the world. In the United States, for example, we will find, if we go around from place to place, great differences in the amount of fluoride in water or in food, depending on where the food is grown and what kind of soil it's grown. And up here on the map, if we go up here on this map, we can take a look. And for instance, if we go to Washington, D.C., which would be over here, that would be no fluoride in the water at all. If we went to Boulder, Colorado, I guess that would be about right here, there would be no fluoride at all. But if you went right near it to Colorado Springs, there would be a lot. There would be 2.5 parts per million. If we went down here to Bartlett in Texas, we would have 8 parts per million in the normal water supply that people drink. Actually, there are 2 areas in the country where the largest concentrations appear, all through here in Texas, as I mentioned, and up through here there's an area. And then there's one that starts up here in the Dakotas, comes down here into Iowa, over here into Illinois and Indiana, and peters out over here. These are 2 areas where the fluoride is particularly heavy. So you see, we have fluoride all over. We have in Massachusetts a few places where the fluoride is more than 1 part per million, but there are places in the country where there are a lot of places of that sort. And it's interesting that if you drink that nice sparkling well water, the deeper the well is, the more likely it is to contain more fluoride. Of course, in general, surface waters from reservoirs, tend to have less fluoride than waters that we get from down deep.
The more pure the water tastes, the more pure it's likely to have fluoride in it.
I don't know if that's true. I don't quite go that far, but at least a lot of sparkling well water has got a lot of fluoride in it. Now, as I said, if you eat food on the average in your diet every day, you'll have 2/10 to 3/10 part per million, or about 1/4 to 1/3 the amount that you would need in order to have the recommended amount per day for the prevention of decayed teeth in children. Actually, there's one food, tea, which has a large amount of fluoride in it, and actually in 10 cups of tea you'll find 1 milligram of fluorine. So you take in 10 cups of tea per day, you'll take in just the required amount of fluorine that would be needed to do this. But after all, children don't drink tea, you see, and we don't recommend tea for children, so we have to try to get it to them some other way. But now, what about this material? Is it going to harm anybody?
Many people think it does.
Yes, they do. And what I thought we'd do would be to take some of the particular diseases that are said to be more common or more common a cause of death and show you just what the deaths are like in the sense of numbers in this country. In 32 communities where fluoride is used, and actually it's used now, I guess, Mr. Wheatley, I guess in 1,140-some communities in this country, making up somewhere around 23 million people are now getting fluoride in the water supply and something of that sort. But let's look a minute here, and we see these dark lines represent the death rates per 100,000 population in fluoride cities, and the death rates in the cities without fluoride, 32 cities that were picked nearby to match the other 32 so that they would be close by geographically but would have no fluorine in the water. And you see the heart disease here. Deaths are the same. The cancer deaths are the same. The deaths ahead here, we had to use a short word. It means cerebral hemorrhage in the skull, strokes. And you see this is the same. And they've talked much about the fact that since fluoride is excreted in the kidney, in the urine, that perhaps the kidney would be damaged. And you see here that the kidney is the same. And then a few words about liver, cirrhosis of the liver, and we see this is the same. So I think we can say that as far as these causes of death that have been so commonly talked about, these causes of death, that there is no difference between fluoride cities and cities where no fluoride is used in the water supply, or where fluoride is not present naturally in the water supply, so that I don't think that there's any evidence on the other side either, Mr. Wheatley. I don't think this is an isolated study, so to speak. I think this represents a very representative sample of what the problem is as far as death rates are concerned. Yes. So we can say that as far as deaths are concerned, there are no differences. That's the first point. But people have said, well, maybe it isn't death. Maybe it's just being sick. Will it affect our children? I think some of our people who have written into the program have said, will it harm children? Well, the best answer to that was obtained in this excellent study on this whole problem, which was done by the New York State Department of Health in New York State at two towns, one called Newburgh, New York, and I'll show them up here on the map, and the other Kingston, New York. Now, they picked these two towns right along the west bank of the Hudson River, right over in here. They're just 30 miles apart on the river here. They're towns that are very much alike, have the same kind of stable population, and way back in 1944, they decided that they would take one of these towns, Newburgh, and the local community cooperated after much discussion, I might say, and Kingston was left to go ahead and not put any fluoride in its water supply. It has no normal fluoride in the supply, with the result that they have been able, since 1944, and now just last December, a report was made, December 55, 10 years after the experiment was done, started, to see what would happen to the children in this community, having all been examined in the beginning before the fluoride was put in, and having been examined again, and they were examined for the following things. First, did the children grow in Newburgh the way they grew in Kingston? Did fluoride have an effect on cutting down their height or their weight? It did not. Did it have any effect on their eyes, and particularly their ears, because there's been some talk about the fact that fluoride might cause deafness? There was no evidence of deafness at all. Was there any evidence about the question of general physical examination? Were they able to pick up any disease? they were not. This has all been carefully written up and documented. So we can say then, as a result of the study, very careful study done by comparing two communities, Kingston, New York with no fluoride, Newburgh, New York with fluoride over a period of 10 years, that there were no differences in the way the children grew or in the way they had diseases in the two communities. But there was one difference, and that had to do with their teeth, and we'll see about that in a moment. It was a major difference. There's an interesting little story about this, Mr. Wheatley. When they first talked about this in 1944 in Newburgh, and they thought they would be starting earlier than they were able to start, a great many people in the community thought that they had started. So they immediately start sending in letters to the newspapers about the way pots were being discolored, about the fact that people were having all kinds of symptoms, how bad the water tasted. And then it was announced, after a great many of these complaints had come in, that they hadn't started the experiment at all. As a matter of fact, they didn't start until 1945. But it is a very interesting chapter in this whole story on the problems of getting fluoride into water supplies for the prevention of tooth decay. I think it's clearly established, Mr. Wheatley, that the stuff is not harmful. There's been some vague talk about its effect on the bones, and a study just published in December, and one of the co-authors of this study was Dr. Merrill Sussman, a professor of radiology at the Harvard Medical School and chief of the X-ray department at the Peter Ben Brigham Hospital. And this study was done down in Bartlett, Texas. You remember we talked about this little town that had 8 parts per million, which is 8 times the recommended amount, so much that they've got to defluoridate their supply now to get it down to 1, which is what they've started to do. Down there, they studied people over a period of 10 years, again, exposed to 8 parts per million, to see whether there was any change in the bones of these people over 10 years. They found some increased density of bone, but they concluded by believing that this slight increase in density might even be helpful because older women, after the menopause, you know, it's very common to have a certain amount of the lime to come out of the bones of older women, and that's one of the reasons why you have these accidents of broken hips and things of that sort when they fall. And it's been shown that in this community, the amount of calcium, the amount of lime in the bones, is at a higher level in such women, and maybe it might even be a little bit helpful to have had that fluoride in the water supply as far as the bones are concerned. So I think that's another aspect. But now it comes to the question of teeth. And when we talk about the problem of teeth, we have a little model over here, which I'd like to show you. And in this model, cut in half, you see, as if it were cut down in the middle, we have this outside part, which is the enamel. This is the part that we see on the outside of a tooth. And this is what we try to keep from having any little holes put in it so the tooth won't decay. This is the material that fastens the root, which is in here, the pulp, to the enamel, the so-called dentine that runs all the way around. Now the blood supply comes in from the bottom, and if you put water, if a person drinks water, which has fluoride in it, it comes through the blood supply, and this is now in a small child whose tooth is being formed. And as you see, as these lines show, the little molecules will go out all the way through the whole tooth and saturate the whole tooth, even the enamel here. The enamel is still in the process of formation. It won't happen after it's formed, but in adults. But while it's still being formed, in the process of formation, it'll get a deposit of fluoride right into that enamel. And if you take a piece of that enamel and measure its hardness, you'll find that enamel with fluoride in it is much harder than enamel without fluoride in it. And this is probably one of the reasons why this stuff works. Now, we can also put fluoride into a tooth by applying something on the outside. But when you do that, all that happens is you get a coating on the outside of the tooth, and it doesn't go all the way through. The way I just showed you, the material taken by mouth, the water drunk in small children, will make the whole tooth harder rather than just a very thin coating on the outside when we apply things on the outside in the form of, either the dentist doing it, or toothpaste, or maybe a lozenge, or maybe chewing gum, or what have you. We just put it on the outside. Now, the question is, what happens if you live in an area where fluorides are higher in concentration or as high in concentration where as high in concentration or higher in concentration they should be in order to protect you from getting decayed teeth. I've got a chart here. Tells us about 2 towns, and there's this item, decayed, missing, or filled teeth. This is the way we measure damage to teeth. It can be damaged in any one of 3 ways. Either it can be decayed with a hole in it, or the tooth can be missing, either fallen out or pulled out, or the tooth can have been repaired, but it means a damaged tooth. Now, there are 32 teeth in our mouths, if they're all there, in adults, permanent teeth. And you see here in Boulder, Colorado, with no fluoride in it, in people aged 20 to 24, something like 14 of these 32 teeth in the mouth were either decayed, missing, or filled. And you see this gradually goes up, as you'd expect, as people get older, from 20s to the 30s and up to the 40s, so that it reaches a level a little over 20. But in a community like Colorado Springs, which is nearby, where they have 2.5 parts per million instead of, or 1 part per million up here on the board, you see that it starts at a much lower level at 6 instead of 14, and it goes to 44 to a level of somewhere around 10 or 11, up to about 22 up here. So actually, it's cut about 60%, actually, is the figure, if you actually calculate it on the average. 60% of decayed, missing, or filled teeth are done away with. 60% of the damage is done away with by natural fluoride. Now, what about fluoride that's put into the water? Does it work the same? Well, it's pretty much the same kind of stuff, but what happens? Well, we have a chart here. Aurora, Illinois, this lower line here, is a place where you have natural fluoridation, actually 1.2 parts per million. And you see how low this stays in childhood, 5 to 16. Starts off at 0 here at 5, and maybe runs up to about 4 or 5 at age 16. But up here in Grand Rapids, which had none beforehand, it started at the same place, but look where it went. It went up here at about 13 or 14 by the age of 16, you see. Now, when they put fluoride into that supply, you see the younger children who benefited from the fluoride being in for 9 years, you see, this is up to age 11, have about the same experience as the Aurora people did. But the older children who were there beforehand and who had their teeth formed earlier, they went on and had a worse experience, although they benefited some. They were better than they were before. And finally, that nice experiment that we talked about, you remember, in Newburgh and in Kingston. I just got a couple little fractions up here to show this quickly. Again, decayed, missing, or filled permanent teeth in 6 to 10-year-old children. 1 out of every 10 in Newburgh at the end of 8 years of fluoridation, 1953, 45 to 53, 1 out of 10 had, as 1 out of 10 teeth in the mouth of these children were either decayed, missing, or filled, but 1 out of 4 in Kingston. Already at the age of 10 years, from 6 to 10 years, 1/4 of the teeth were already either decayed, missing, or filled, you see. And that's really a very serious problem. And the putting of fluoride into water is not something one does for the joke of it, but this is really a serious problem that you can do something about if fluoride is put into the water supply. Now, I think, Mr. Wheatley, we've demonstrated that the material is not harmful in the amounts recommended, although in very much larger amounts it might very well be toxic, as many substances are, and also that it's helpful, that it cuts down decay 60%, cuts down the number of decayed, missing, or filled teeth about 60%. If it's given so that children can get it in the water supply while their teeth are still being formed, that means their baby teeth and their permanent teeth. And it's important for both because if the baby teeth are kept in the mouth, the shape of the jaw is preserved. If they're kept in for a longer period of time until the permanent teeth have a chance to come in and frame out the jaw. Now, how are we going to do this? How are we going to get this water how are we going to get the fluoride into the water supply? How is it usually done? People want to know, one of the first questions they want to know is whether or not this material can be tasted in the water. I've got 2 bottles over here, Mr. Wheatley. And I've got 2 glasses for you.
For me.
For you. And I've got a bottle here of some water from down in Hingham, where they fluoridate their supply. I'm down there and got some water before they put the fluoride in, and got some of the same water after they put the fluoride in. And I want you to taste them and tell me how the fluoride tastes. to try this?
Well, I avoided reading which label was on which bottle.
Well, it doesn't make any difference. You go taste it. Tell me which one tastes better.
I don't want any suggestion here.
Just tell me which one tastes better.
Dr. Rutstein, I may not have the right answer. I like this one.
You do?
Yes.
Well, that one was the one without the fluoride in it.
Without the fluoride?
Yeah. You think you can taste it?
I don't think so, really.
You don't think so?
I doubt it.
Well, I just had some. It tasted to me like ordinary water, but I would recommend that anyone would like to try this. I'd recommend they go down to Hingham and get some water.
I can't really tell.
Or go to any community around the country where they might have fluoride in the water supply. Well, in any event, many tests have been done, and you can't taste it until it gets way up into the hundreds of parts per million, until you can begin to taste it. And it's also colorless, as you see. It's perfectly sparkling. Both glasses are about the same. Now, if you have a water supply, this is the best way of doing it, putting the fluoride in the supply, because we know the dosage. We know that in Newburgh, over a period of 10 years, the amount of caries was cut down. Same kind of thing happened in Brantford, Ontario, Grand Rapids, the one chart you saw up there. So that we know the dosage, we know approximately how much people drink per day, and the range of drinking. That is, every child doesn't drink the same as every other child. Even within the range of drinking, within a climate like Upper New York State, it's perfectly satisfactory. The range is not toxic, it's not poisonous, and it seems to be quite effective. Of course, in southern United States, in hot weather, you would have to have lower concentrations, and actually in Charlotte, North Carolina, they are adjusting the level of the fluoride in the water supply of the community so that it's lower in the hot weather when people drink more water, to keep the amount taken in per day about the same, you say. Well, now other things have been recommended besides water, and of course many of you may not have a water supply. Many of you may have your own wells. Of course, if you have a deep well, you may have some fluoride in your well. But you'll have to find your fluoride in other ways. You'll get some in your food, as I showed you. But probably the best thing to do for your children is to have them go to a dentist, and about the age of 3 years, and again at the age of 7 and about 12 and maybe about 15, and have it applied by the dentist in the form of a solution. We have a solution here of a 2% solution of this material. This is the stuff that the dentist uses, and this material could be tasted. And actually, when the dentist puts it on, he puts pads all around the teeth so that the stuff can't get into your mouth. But you see, it's a perfectly clear solution, and this is the ordinary material that he would rub on a tooth.
What ages?
Age 3 first, and then age about 6, and then somewhere late in childhood 9, 12, 15, something like that.
Only if it isn't in the water supply?
Only if it isn't in the water supply, that's right. Other ways of getting it, recently recommended, of course, are things like toothpaste, and some people have suggested chewing gum and lozenges. The difficulty with getting fluoride this way is that we know nothing about the dosage. There is one experiment that shows that fluoride in toothpaste does cause decrease in decay, but the dosage is so irregular. There's only been one study, and if you take toothpaste one day and take some fluoride in your water supply, and that may vary from place to place, and if you take chewing gum or take some lozenges and so on, we just don't know where you stand. More than that, the law at the present of the federal Food and Drug Law does not require the manufacturer to put the amount of fluoride on the toothpaste tube, and you'll see if you look on toothpaste tubes that are supposed to have fluoride in them that no amount is specified. So that, as a matter of fact, the law only requires that the manufacturer guarantee that the amount be safe and not be harmful. So that we can't tell what the dosage is until we have much more information about dosage through toothpaste, which will only then coat just the outside of the tooth now. Coming back to our model here a minute. It'll only coat the outside of the tooth anyway. It doesn't go all the way through. It would only be used in places where you wouldn't have a water supply. but probably best given by the dentist because he knows how much to apply and knows the exact dose, or perhaps by a dental hygienist in schools. That's been done in some communities too. It's useful to have topical fluoride. We need more information about it. We can make no recommendations at the moment.
No recommendations?
In favor of it at the moment. No strong recommendations except in those areas where no fluoride in the water supply, and there we'd recommend topical application by the dentist as the first choice. This is where we stand.
Is there any evidence now about the use of any of these other means, toothpaste, lozenges, and so on, for adults?
This would only be for adults, and we have no evidence that such the treatment in adults really makes very much difference.
Because the water supply being treated with fluoride.
We have no evidence about that either, really. We only know that if people stay in the community, as you saw in this chart with Boulder, Colorado, that they apparently preserve their ability. Well, now, Mr. Wheatley, we, I think, have gone through this story. We'll come back to your first question, and that is, why is there so much opposition? And the answer is, I don't know, unless it has to do with the fact that when anything new is introduced and put into some of our food that we don't know anything about, that the unknown scares us. And that being the case, perhaps a lot of people are just fearful. But I think people should look the facts squarely, look squarely at these facts, and then try to see whether or not you wouldn't really appreciate having fluoride in your supply, because when you think of all the dentures, and I think of my fillings in my teeth, and I think of tooth extractions I've had, and think that that can be cut 60% for my children and for your children, I really think it's worthwhile. Thank you very much.
Dr. Rutstein, this evidence in favor of fluoridation is about as complete as you can have scientific evidence be complete?
I would think so, for water supply for children. We don't have the evidence yet on the adults. We'll get that as we get more information about applying it from the outside. But as far as children are concerned, as far as putting in the water supply during the period of formation, I don't see how you can have better evidence.
Thank you very much, Dr. Rutstein.
The Facts of Medicine has been presented by the Harvard Medical School and the Lowell Institute with Dr. David D. Rutstein, Professor of Preventive Medicine, Harvard University, and Mr. Parker Wheatley, General Manager of WGBH TV. The Facts of Medicine is made possible by a grant and aid from the John Hancock Mutual Life Insurance Company, is directed by Paul Rader, and produced in the studios of WGBH TV, Boston.